Okay guys, so this is the homework for tonight. So we did this together in class, like each class did maybe some different things, but basically we did do some practice on this side. And remember, we're using the Pythagorean theorem to find distance between 2 points. A lot of students don't put that connection, they don't make that connection, so I really am hoping this year that you guys will be able to make that connection, that when you're being asked to find the distance between a pair of points in the coordinate plane, you can always use the Pythagorean theorem, okay? So you can use the problems that we did in class to help refresh your memory, and I would say before you even watch the video, I would pause it and see if you guys can look back on these problems and use it as a guide on how you would do these problems, okay? So I would strongly suggest that you pause the video right here and try to do as much as you can on your own. When you get stuck, then just watch a little bit of it and then pause it to see if you can do the rest on your own. Don't be completely dependent on me. Or if you are, be dependent on me for one problem and then do the other problem completely on your own. So let's take a look at number 13. First, notice that this is if this is a hypotenuse or a leg. And in this case, it's a leg because it's completely vertical, or if it's completely horizontal. So it's countable, which means, let me see, this is not quite focused. Hold on. Okay, so maybe that helps a little bit. So you put your pencil at the end point of 1. You can start here or you can start here. Either way, it's going to count the same, right? So let's say I start here. That's 0. I haven't moved my pencil yet. As soon as you start moving, it's 1, 2, 3, 4, 5. So this here, the leg is 5 units long. I have someone trying to...
Please, no common assessment.
Oh, hold on.
I can't take it.
It's okay. I'll come talk to you in a second. Oh, it's okay. It's okay. Sorry, I should have. It's okay. So then over here, you have 2 endpoints, right? So this is a hypotenuse. So you're going to have to create legs, okay? I'm going to have to go all the way down, and then over here, and then a leg, okay? So then we have... you could have gone this way too if you wanted to. But now that we have that, this is our hypotenuse, and we'll call that our x. And we're going to have to use Pythagorean theorem here. So this is your C, this is your A, this is your B. Remember, C is always your hypotenuse. The nice thing is we can always count how long the A's and B's are. So let's see. We got an A here, so it's 1, 2, 3, 4, 5. Okay. And then let's see how long this side is. 1, 2, 3, 4, 5, 6. Okay. So we got a squared plus b squared equals c squared. And if you're going to pause the video, this is a good place to pause and then see how you do. Okay, so the legs are 5 and 6, so 5 squared plus 6 squared equals x squared. 25 plus 36, because 5 squared is 25. 6 squared is 36. Rewrite the equals, rewrite the x squared. Add these together. So 25 plus 36 is 61. I'm doing this in my head. I hope I did it right. I think I did. Equals x squared. And then square root both sides. And then if you square root the x squared, these cancel out. So therefore, the x is by itself. Okay? Some of you guys are still making errors here. Do not circle this yet. That's not your final answer. Your final answer is when you have an x by itself. The question is what's happening on this side. There's no squared here, so nothing cancels with the square root, so the 61 stays stuck under the square root. Do not say x equals 61. That is completely wrong, okay? And then the approximate, I want you guys to get in the habit of writing that, okay? Get used to trying that. So I need to take the square root of 61. I'm going to do it on my computer. I have a little calculator on there. 61, and I take the square root, comes out to be 7.810. So it rounds to 7.81 units. So let's see if that makes sense. Yeah, if the 7.8 is here, it's the longest out of these 3 sides. So yeah, that makes sense. Okay? All right, number 18. Number 18, we have another hypotenuse. So we're going to have to create legs. Now, you can go to the right and down, or you can go to the left and up. I'm going to go down and to the right and make it a really skinny right triangle, okay? So then you have to figure out what the legs are, right? So you got to count. This one's easy. It's just 1 unit. And then from here, let's say you can go 1, 2, 3, 4, 5, 6, 7, or you could start here and go 1, 2, 3, 4, 5, 6, 7. All right. So we have well, let's start with a squared plus b squared. A squared plus b squared equals c squared. So then we have a 1 squared plus 7 squared equals x squared. Then we have 1 plus 49, because 1 squared is 1, 7 squared is 49. Okay, once again, I'm hoping you're pausing the video and only checking your answers. Okay, so I had to square root both sides to get rid of the square, and then the square root and the square, they cancel each other out. But here, there's nothing to cancel out, so you leave it under the square root. So this is your exact answer. And the approximate answer is going to be, let me put that in my calculator, in my computer, so 50 square root that. It's 7.01 or 7.1 approximately. All right? Now 20 is going to require a little bit of work, and that's why I gave you guys graph paper. Let me go get some grid paper. Okay, I'm going to use this one that I used in class. I'm going to make one for number 20. So I'm going to take a look here. I need enough room for 6 comma 4, but I also need enough room for -5, -1. So I think I'm going to go like maybe 6 by 6, maybe even 7 by 7 to have enough room for everything. So, all right, and this is just trial and error. Sometimes you try something and it doesn't quite work, and then you have to try again. The biggest tip I can give you is that make sure you actually use the grid. That's why I'm giving you grid paper. The y-axis should be like literally on the line. Don't be like somewhere halfway between. Like that's really hard to figure out, okay? So there's y-axis. Someone's playing a video game outside. Okay, sounds like Tetris. Okay, so we have, and this too, make sure that's literally on the line, right? All right, so then the other tip I have is literally make your little marks, okay, so that gives you a guideline of where to place your numbers. And you know, at least get it started, and if you need more, just extend the line, okay? So here I go. And the other thing is you have to know, okay, there's where I put my number, here, 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 and these are positive on this side, right? Going away from the origin, you have a -1, a -2, a -3, a -4, -5, and then a -6. Okay, so I'm not using this one right now. All right, and then up here, this is 0, and then this is 1, 2, 3, 4, 5, 6, 7, and then this one's -1, -2, -3, -4, -5. Hopefully that's enough. So I have these points. I have 6 comma 4. That's, oh, yeah, I need to go one more. 6, okay? So I go 6 to the right, and then up 4. So 6 to the right, 1, 2, 3, 4. There's my 6 comma 4. If it helps you to write it. We didn't do that in class, but if it helps you, go for it. The next one is -5, -1. Okay, so that means I have to go -5 on the x-axis and then go down -1. So -5, -1. So this thing stretches all the way across, okay? If you have like a straight edge, I'm going to use whatever I have available. Here's one of my popsicle sticks, okay? Anything you have, if you have a ruler, just connect it. If you don't have any of those, then just freehand it. So this is what I'm trying to find. And since it's going diagonally, this is the hypotenuse, I could create legs. Now you can go down, but right now, that's a lot of stuff going on here, so maybe I'll just go up. So if I go up from this point, if I go up too high, then I'll have to go to the other point by a diagonal, but I want to follow the grid. So here's my other leg, and here's where the right angle happens. So then, since we're trying to find the hypotenuse, we can count the legs. Let's see here. This leg, I start at 0, then I go up 1, 2, 3, 4, 5. Okay, that leg is 5. Okay, and then from here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That leg is 11. Okay, so then I'm going to just do my work straight on here because if you look, there isn't a ton of room, and I've already used up some of the space from 18. So it's fine. Number 2, or 20, I'll say this is number 20. Okay, so a squared excuse me, plus b squared equals c squared. Well, we know that in this case the hypotenuse is x squared, but then we got 5 squared plus 11 squared. So then what is 5 squared? 25. 11 squared, 121. Okay, we still got x squared over here, and it's okay if you're using c. That looks like it's going to be 146 equals x squared. No, it's not 146. Yes, it is. Okay. And then square root both sides. Square root of a squared becomes just x. There is no square to cancel with this, so therefore this is just going to stay stuck under the square root. So this one has a square root, this one doesn't. Okay, and that's when you're done. And then you're going to take the approximate. So let's go ahead and take the square root of 146. I'm going to use a calculator on my computer. 146 square root. It comes out to be 12.08, which rounds to 12.1 units. So that means this side right here is about 12.1 units, which makes sense. It's the longest side, longer than 11, longer than 5. Okay, it's a reasonable answer. So if you want to try again and you're coming in for tutoring, then you can show this worksheet to whoever's tutoring you in the morning and say, hey, I need help with more of these. Can you help me make sure I know how to do this? Or you can do more problems that are in the graph, okay? All right, so that's the end of this video.